Okay, greeting everyone. In previous class we have discussed about what is the concept of current and how to calculate instantaneous current and average current. But to actually understand what is the exact current or what is the concept of current in the conductor, so for that we have to discuss first of all what is free electron. So in today's class the goal will be to understand the concept of current in a conductor. We know mathematical expression what is current and how to evaluate average or instantaneous, but to understand the concept of current in a conductor, first we have to understand what is free electron, because at the end they are the one who produce current in a conductor. To understand free electron, also free electrons are known as conductive electrons. To understand free electron, first we will discuss what is free electron. For that we have to discuss either we can discuss energy band or we can discuss metallic bond. There are two ways by which we can define what is free electron. So in today's class we are going to discuss both of the methods to define free electron. First is energy band and second is metallic bond. Okay, so remember the goal of today's class is to understand the concept of current in a conductor. For that we have to understand the concept of free electron. Okay, so first we are going to understand free electron with the help of energy band theory, and your free electrons are also known as conductive electrons. Okay, right. So why it is conductive electron? Because these are the only electrons which are mobile and which can produce current. So what to understand free electron, we are going to understand first of all what is energy band. Okay, so as you can see, energy band, the definition I have written, and there are few diagrams, but first we have to understand what is energy band. Okay, so how we can understand energy band? Imagine you have an isolated atom. If you happen to have isolated atom, what will happen? Each electron of that atom will get influenced by only that nucleus of the atom. Means if you have this an isolated atom, it will have some orbit, right? And because there is only one nucleus, the influence on the electron will be only due to this particular nucleus, and in that influence each energy level, orbit is also known as energy level, will have defined energy values. Defined energy values means here your orbit will be discrete, right? And here you can see also the same thing I have written. For an isolated atom, the valence electron can exist only in one of the allowed orbitals which offers sharply defined energy called energy levels, because there is no other in isolated atom, the influence is only due to one nucleus. So in just single nucleus, the energy level is well defined, sharply defined. As you can see also, where we have diagram, you can see this. You have seen similar diagram in the class 11 structure of atom. So each energy level are well defined. First energy level, second energy level, third, fourth, and so on. Even if you follow this Conductors wave equation also, the energy level will be defined. So in a single atom, the energy levels are defined: first, second, third, and valence shell. But in a lattice of crystal, where there are multiple atoms, what we will have? See, first I will show you what is lattice. First, like you can see, so lattice is what when you have when there are many atoms arranged in a way, and if you connect them by imaginary line, you can see connect them by imaginary line, so they will form some geometry. That geometry is called as lattice. For crystal, most of the time that crystal will be formed by a similar lattice. It will have n number of lattice and it will form some crystal. So lattice is just nothing, it is just arrangement of atom in a crystal. And when you will have lattice of crystal, so what is going to happen? There will be many nucleus, right? There will be many nucleus, just like that. Let's say we are talking about any particular atom, for example this. For that electron, the influence on this electron will be due to many nucleus. This electron will get influenced by this also, and many other nucleus. So in the influence of many nucleus, it cannot have sharply well defined energy level. Rather than that, it will have very close energy levels which are very close to each other, and it will have like this. For an so atom in a crystal, what you will see that instead of having sharp well defined energy level, it is going to have energy level, many energy level which is very close to each other. And this is just, we are talking about first energy level, and after some gap there will be second orbit, and instead of single well defined orbit you will have many energy levels which is very close to each other. See in the diagram you will see it seems like they are intersecting each other, but actually they will not intersect each other, but rather than that they will be very close to each other, right? So if I draw the diagram from Niels-Bohr's also, so it will look like this. This will be your first energy level, right? Again, instead of energy level you will have many energy levels which is very close to each other, and it is due to influence of many nucleus, right? And after with some gap of energy there will be same theory for second energy, right? So in a crystal, atom's electron will get influenced by many nucleus. In that influence, it cannot form a well defined energy level, rather than it will form energy level which is very close to each other. So rather than drawing many energy levels which is very close to each other, we can do what? We can draw a band of energy which is known as energy band. Are you getting what is energy band? So again, if I explain you, so if you have an atom which belongs to a crystal, in the influence of many nucleus, it will have many energy levels which is close to each other. And if you see, because they are very close to each other, rather than drawing them separately, we can draw a band of energy that will be known as energy band. And here you can see same thing I have written, right? However, when two or more atoms are brought near to each other, then there are alteration in energy levels, and they spread in the form of band as shown in the figure. So there will be many energy levels which is very close to each other. So there will be energy band for first level, second level, and third level, and last will be your valence band, right? So what is your valence band? Nothing like just whatever I explained. Let's say if you have an atom, for example, you have sodium. So we know valence electron is in last shell, right? So similarly, because this sodium is not isolated, it belongs to some crystal. So the last energy band will be known as your valence band. So what is your valence band? It is the last energy band where electron can be found in an atom, right? The energy band formed by a series of energy levels containing valence electron is known as valence band. Got it? And if you want to remove electron from the valence band, what you have to do? You have to provide some energy, right? You can get it by thermal also, or you can give it by some other process also. Means if they haven't have any energy, then all the electrons are going to be valence band. And same thing has been written here. Right? At 0 Kelvin, all the electrons will be in valence shell or lower than that. Got it? until they get energy from somewhere, it cannot exceed from valence band. So this is the last band of energy where electron can be found at 0 Kelvin. Right? If they get energy from thermal, then they can get excited and they can leave the nucleus, and they can be known as like ionized electron or something. Got it? So here we have shown, like, instead of one first orbit, you are having what, many energy levels, second, fourth, second also, and third also. And if it is last energy band, this can be your valence energy band. And remember, at 0 Kelvin, all the electrons will be in valence band or lower than valence band. Got it? Now we have conduction band. And if you remember, why we are discussing, to define the free electron. So same as this picture, this is, let's say this is your valence band, and if the temperature is more than 0 Kelvin, if the temperature is more than 0 Kelvin, what can happen? Because if it has more than 0 Kelvin, it can get thermal energy. It can get thermal energy. And what will happen? Let's say there is electron here, and once the temperature is higher than 0, it is possible that you can have a photon which has suitable energy, and it can knock the electron out of valence band. And once this electron has been knocked out, so where it will go? It will go to a region or a band which is known as conduction band. And the electron which is jumping from valence to conduction, these electrons are known as your free electron. Let me show you here with the picture. This is your valence band, and there will be electrons here. You can say it is valence electron also, and there will be a higher energy level or higher energy band. This will be your conduction band. So if the temperature is suitable enough, or the energy of photon is suitable enough, it can do what? It can knock the electron from valence band. And once the electron has been knocked out, it will jump from valence to conduction band. It will jump from valence to conduction band, and these electrons which jump from valence to conduction band, these electrons are known as free electron. Why free electron? These electrons are known as free electron. Why? Because now once they are in conduction band, the attractive force due to nucleus is nearly negligible. So because the attractive force due to nucleus is nearly negligible, so these electrons are mobile. These can move easily. And for current, what you want? Charge which can move easily. Or what you want? Electron which cannot leave the orbit. Definitely you want electron which can move easily. So what is the definition of free electron? Again, if we summarize, what is the definition of free electron? If you have any atom which belongs to some crystal, in the influence of many nucleus, it will form many energy levels which is close to each other. So first energy band, second energy band, third energy band, and valence energy band. Right? So remember, this theory is from valence band. So if the temperature is more than 0 Kelvin, why we need more than 0 Kelvin? Because if the temperature is less than 0 Kelvin, they will not get energy to jump from valence to conduction. So in a atom which is part of some crystal, there will be many energy bands, right? First, second, and third order valence band. So if electron gets sufficiently high energy, it will jump from valence band to conduction band. And here the pull of nucleus will be nearly negligible. So this can move easily with nearly no force. So these electrons are known as free electron, and they are mobile, because they are nearly no force, and these electrons are the only one which cause conduction, right? If these are the only electrons which are responsible for conduction. So electron in any energy band, valence band or lower than that, will not cause any conduction. The only electron which is in conduction band can cause conduction or conductivity. That's why the name is conduction band. And you can see also, and remember, to jump electron from valence to conduction band, you need some energy. That is only possible when the temperature is 0 Kelvin. Means at 0 Kelvin there will be no electron in conduction band. Got it? So the lowest unfilled allowed energy band next to valence band is called conduction band. At 0 Kelvin, the Fermi level and other lower energy levels are occupied completely by electrons, and that means conduction band is empty. And see, the band is also called conduction empty band of minimum energy, because after that, if the energy increases, the electron becomes free and no one. Okay. What is the meaning of this? Means, just like I told you, once electron get energy, it jumps from valence to conduction band. Okay. So here the pull of nucleus is nearly negligible, but still it hasn't leave the nucleus. Means it the force due to nucleus is nearly negligible, but it is not zero. To actually remove this electron from the arc or from the binding energy of nucleus, you have to remove from here. If you give any energy from this point, it can become ionized electron. Got it? But still here, because the pull of nucleus is nearly negligible, these electrons are mobile, so they can cause conduction. Got it? And you can see current flows due to such electron. That's why they are called as conduction electron also, or free electron. Got it? So in your, you can have a look on this also. If you want to take SS or something, you can take it. Okay. So you can see the picture also, the previous picture, if you remember. Just now we have discussed valence and conduction band. So these energy bands, they have been separated by some gap. So this is the maximum value of valence band, and this is the minimum value of valence band. This is the minimum value of conduction band, and this is the maximum value of conduction band. So the energy gap between them, is known as forbidden energy gap. Is known as forbidden energy gap. And how do you calculate it? You do minimum value of conduction band minus maximum value of valence band. And there is no electron which can be found between valence or conduction band. That's why the name is forbidden energy gap. Okay. Then there are other things you can see written here. Okay. Now we are coming to the important part. See, just you understood what is free electron, and to have conductivity, what you want? More free electron in conduction band or less free electron? Obviously, if these electrons are the only one which can cause conduction, you want more free electron in conduction band. And when it is possible? When it is possible? When the gap between valence or conduction band is small, it's very small. So they can easily jump from valence to conduction band. Otherwise, what will happen? If the gap is too large, they will need higher photon, or a photon with higher energy level, which can only knock the electron from valence to conduction. So that means the conductivity, if you want to talk about the conductivity of any material, it directly depends on what? Number of free electron. And number of free electron is directly depends on like how easily you can get free electron in conduction band. So if we are talking about at a normal temperature, like not high enough temperature, like temperature around 25 degrees Celsius, something like that. So conductivity directly depends on number of free electron. Okay. And you can see number of free electron will depend on how small is the gap. So you can see it is inversely depends on what? Forbidden energy gap. If the forbidden energy gap is small, electron can easily jump from valence to conduction band, and they can cause more conduction. But if the gap is large enough, then they will be they won't be a good conductor, and the conductivity will not be high. And that's why the definition or the difference of conductor, insulator and semiconductor are also arranged in the terms of. So what I was discussing right now, that conductivity in any material depends on number of electron, and that depends like how easily it can jump from valence to conduction band, and it can jump only when the gap is very small. Means it can easily jump only when the gap is very small. So on that basis, means on the basis of forbidden energy gap, we can define conductor, insulator and semiconductor. You can see for conductor the energy gap is quite small, but for insulator it is quite large, and but semiconductor it is between conductor and insulator, right? And for reference, 1 electron volt is very small energy. It is 1.602 into 10 to the minus 19 joule. And what is 1 electron volt? You can actually understand it by like this also. If you have point A and if you have point B, it is the definition of 1 electron volt. And if you have electron at B, imagine, and you are bringing electron from B to A, and the potential difference between this is what? 1 volt. So the work done required to bring 1 electron from B to A, where the potential difference is 1 volt, the work is equals to, if you are writing external, the work is equals to 1.6 into 10 to the power minus 19 joule. And that's how we have defined 1 electron volt. Right? How much energy is required to move 1 electron from B to A, where the potential difference of B and A is 1 volt? The energy required is known as your 1 electron volt. Got it? And here are a few examples of energy energy gap between conduction and valence band. And you can see these are like not the most important example, but we can use this example for this reference. You can see for sodium, the gap is very small, and actually the gap is around 0.01 electron volt. But for zinc, you can see they are actually overlapping, right? They are actually overlapping. So that's why for metals, they are very good conductor, because the gap between conduction and valence band is so small, or sometimes they actually overlap. So electron can easily jump from valence to conduction band. That's why they are good conductor. Okay. So again, why we were discussing all of this? To understand the concept of free electron. Okay, I'll give you again a quick recap. What is free electron? Right? If you have a single atom, we know the nucleus, there will be only one nucleus, so the influence will be only due to one nucleus, and the energy level will be discrete and sharply defined. But the moment you will get a lattice where there are many atoms, electron will get influenced by many nucleus, and instead of having one energy level, it will have many energy levels which is close to each other. This is the all the number of energy level close to each other. Then this is the one and this is the one, and these are known as energy band. What is energy band? In the influence of many nucleus, they will form a number of energy level which is very close to each other, and the difference is very small. So instead of drawing them separately, you can draw energy band. And remember, none of them will have exactly one value, so none of the line will intersect each other. So you will have first energy band, second energy band, and third energy band, and the last one you can say valence band. Got it? So in this case, if the electron gets knocked out, it can reach to a band which is known as conduction band, right? And the moment it will reach to conduction band, it will become mobile, because the pull of nucleus will be nearly zero. Again, it is not zero, nearly zero. And that time these electrons will be known as free electron. So this is the definition of free electron, and this is the only electron which can cause conductivity, because they are mobile and they can move freely. So we have defined free electron with the help of energy band, right? You will study this again in semiconductor. Now we will define free electron with the help of metallic bond, right? So here we have written the definition of metallic bond. If you want, you can read it. Okay, so for example, what we are going to talk about, copper. So any metal, whether it is copper or something else, except mercury, they have some lattice and they are arranged in some particular lattice. For copper, for reference, they are arranged in FCC. Actually, you had one chapter that is known as solid state. That chapter would have actually taught you what is lattice and how the atoms are arranged and all, FCC, BCC and all. But that is deleted portion. But maybe for advance you have to study. So in a lattice of metal, if there are many metallic atoms arranged, so how they are bonded together, and why we are interested in their bond formation? Because we know metal does not form covalent bond. Actually, realistically, no bond is covalent or ionic. Every bond has some bits of covalent or ionic character. Depending on if it has more character of ionic, it can be ionic, or if it has more character of covalent, it can be covalent. But that is not the topic we are here to discuss. That is in chemistry. Someday we will discuss that. But if you have many atoms in a lattice, they can be arranged like this. It is a depiction, like, but not exactly it is like this. But if you search on internet and see the spectrography of copper or any metal, you can see it will form somewhat like this kind of lattice. So what happens? You have many atoms in a lattice, and let's say the temperature is above 0 Kelvin. In that case, there will be many photons, energetic photons, which can knock the electron from one atom. So what happens here actually in the lattice of metal, some of electron gets excited and it jumps to another atom and it forms cation and anion. Not just for these two, there will be many atoms which will do this transaction of electron simultaneously, and this transaction lasts for very small duration, and this creates what? Cation and anion, and this lasts for very small duration, like less than a nanosecond. And just after this transaction, there is a possible chance another atom will give the electron, and this will become neutral, and this can become also neutral. But it does not end there. It again do the transaction, electron jumps from one end to another end, and so forth. Like if there are 100 atoms, 70% of the atoms, 80% of the atoms are doing this transaction continuously. They are getting positive, they are getting negative, and so forth. They are doing constant transaction, and this constant back and forth transaction creates what? Temporary cation and temporary anion. So this temporary anions and cations creates what? A bond between atoms which holds them together. You can imagine like this, like you have a bond where there are more than 10, 20, 40, 30 dogs, and imagine they are equally strength, and let's say there are 40 dogs, and someone has dropped, let's say, 30 bones, right? Not for exact number. So each dog is going to fight for a bone, right? So sometimes, because they are equally strength, so what will happen? Sometimes one dog will snatch that bone from other one, and someone will have left with nothing, and they will again chase the other one, and they will be constantly chasing that bone, and that constant transaction. One will try to get the bone, and one will try to hold that bone, and so on. So this constant transaction will let all the dogs together. They will not be liking each other, still they will be fighting to each other, but still they will be pulling the bone from each other. And even if you open the door of that barn, none of them are going to leave that barn, because they are constantly in that struggle that they want that bone back. Are you getting it? Similarly, you can see this constant transaction of electron from one atom to another atom. It is not permanent. It constant transaction one atom to another atom will create what? A temporary cation anion, which is going to hold the lattice together, and these electrons act as glue. And these electrons are, which electrons are actually jumping? The valence electron, and these electrons are known as free electron. So in a lattice of a metal, the valence electron, which jumps from from one atom to another atom, it constantly jumps from one atom to another atom. So you can see the motion is not going to be a smooth motion. So these electrons are known as free electron, and it acts as glue for the lattice, and it holds the lattice together. Are you getting it? So in this definition of free electron also, or the previous definition of electron also, the electron which these electrons are constantly in motion. They are rapidly moving from one point to another point, and that's why they are the one which can create, or which can make the conductor conductive. Are you getting it? So this is the definition of free electron. Whether you study the free electron from energy band concept, or you understand the free electron from metallic bond. In both the case, this is the only electron which can cause electricity. Alright. And once when we are talking about free electron, so it is good to discuss about free electron density. Free electron density. So what is free electron density? If you have a conductor of, let's say, V volume, remember all the electrons are not free electron, only the electron which can do constant motion is your free electron. Got it? Most than the valence electron of an atom can become free electron. So if you have this conductor, or you can have any material, it will have many electrons which can move easily. So these electrons are your free electron. So what is your free electron density? It is represented by small n. It is number of free electron per unit volume. That is the definition of free electron density. You can write capital N over volume. Right. For reference, copper, the free electron density of copper is 8.4 something into 10 raised to power 28 per meter cube. Means if you can imagine a box which is 1 meter, like if you take from this point to this point, this is somewhat your 1 meter, and you can take another 1 meter, and you can imagine a cube of 1 meter. In that cube of 1 meter of in that cube of copper, which has 1 meter cube volume, you will get this many free electron. Remember, it is not total number of electrons in that copper. It is just those number of electrons which can move constantly. These are your free electrons. So you can see it is very high, and for most of the metals the order will remain same. For example, for iron it is 5 point something, but order is still same. So they have very high number of free electron density. Remember, metals have very high number of free electron density, and the reason is pretty clear, because valence and conduction band are very close. They can easily jump from one band to another. And most of the time they actually overlaps. So there is hardly any gap. So there are high number of free electron density. Now once we understood the concept of free electron density, then we can begin the concept of current in a conductor. So what is the major target we had? We had to discuss the concept or mechanics of current in a conductor. Remember, this mechanics or this theory is little old theory. The theory which we are going to discuss, it is old theory, but for beginning this theory is fine. But if you go for higher study, or maybe in the upcoming class, I will exactly tell you what is the concept of current. But for now you can rely on this old theory. It has some flaws, but it will not let you down in terms of numerical or getting answers, because so far in 12th class you will not study any updated theory. Okay, so we are studying the concepts of current in a conductor. So for that we have to discuss in stages. So this is your stage 1. Stage 1, where we will discuss about conductor which is isolated. It is not connected to a battery or something, so it is isolated. So in if you have an isolated conductor, and let's say the temperature of conductor is more than 0 Kelvin. Why we are not taking at 0 Kelvin? There are two reasons. First of all, we have to understand the concept of resistance for that, and secondly, theoretically you can or experimentally you cannot reach to a temperature at 0 Kelvin. Okay, so we are discussing conductor which is not connected to a battery, and there is no electrical and such. This is just a simple normal conductor. And what we are discussing about this simple normal conductor, that if you imagine that if you happen to have a metal, whether it is copper or iron, it is not connected to a battery or something. So does it produce current or not? We know it does not produce current, but why it does not produce current, that is also important to discuss. You might think it is not connected to battery, that's why it is not conducting, and you will not be wrong, but it is not the most exact definition which I want to hear. Okay, so imagine that you have a conductor which is not connected to any battery, or there is no electric field. So in that conductor you will have something called as kernels. And what is kernel? Just earlier we have discussed, like in metallic bond also, some there will be temporary formation of cation and anion. So the atoms which is actually losing the free electron, they are known as your kernels. So there is your kernel. And then there will be free electrons also. There will be free electrons also. And because the temperature is more than 0 Kelvin, so these free electrons will get some kinetic energy, and because of this kinetic energy they will be constantly moving in random direction, and they will have constant collision with kernels. They will be moving here and there and so forth. And the speed of electron is not ordinary or small speed. It is 10⁶ meter per second. It is 1/100th of the speed of light. It is a very large speed, and because of this constant motion they are producing current. But the thing is, because of their random motion, the motion is so random, they are producing current in all random direction. Like if this electron is producing current in this direction, this being cancelled out by other electron which is moving opposite direction. This constant random motion of electron is producing current, but the overall average net current is going to be 0. See, here we have shown also. Let's talk about the individual electron, or we will talk about all the electron also. They will start to move from one point and they will have constant collision going with some velocity u1 and u2, u3 and so on, last you can un. Because of this constant collision, their initial and final point is going to be same. Correct? So actually they are not making, or they are not reaching to any point. So if you find the average velocity of electron, it is going to be approaching to this is the symbol of average. It is going to approach to 0. It is true for single electron also, and it is true for all the electrons velocity combined also. Means if you take the average velocity of all the electrons, or even if you take the average velocity of individual electron, it is going to be 0. The motion is so random, the average velocity of each electron is nearly approaching to 0. Right? Here we have written also. And because they are moving, so they are producing current, but overall net current is going to be approaching to 0. So there is current, like a significant amount of current is being produced, but there is not overall net current. It is being cancelled. So the electrons are constantly moving if the temperature is above 0 Kelvin. So in any case, if the temperature of any metal is above 0 Kelvin, they will have electron which is constantly moving. That means they will have current, but the motion will be so random that the net current will be 0. Right? Because average velocity is going to be 0. So this equation is very important. We will use it later. Now we have to discuss what will happen if you connect in your conductor, or if the conductor is in the presence of some electric field. So we know electric field creates some force on electron. So we have to discuss what will happen if there is a conductor in the influence of electric field. One picture to express, or I will show you here. So if you have this conductor and there is an electric field in the influence, or external electric field, so we might think because of this electric field electrons are going to experience some force, which is not wrong. They will experience some force. they will experience some force, right? But because the electron density or the free electron density for the matter is so high, what will happen? You can see in the picture also, I have mentioned, you can see the picture also. Because of this electric field, each electron is going to experience force in left direction, so electrons will get accumulated at one of the end of conductor. It doesn't mean there will be no electron here, there will be, but the number of electrons is going to be less. See, at any case, the conductor is going to be neutral. Previous or this case also. So you can see the majority of electrons are here, and still they will be moving at random direction. They are accumulated here, but the motion will not stop. They are still moving randomly. But because of this accumulation of major negative charge here and less negative here, so this will create a charge difference, and you know, whenever there is a charge difference, there will be electric field, and this will be, this electric will be what? This is more negative, this is less negative, so you can say this electric will be like this, and this electric field is not ordinary, it is called induced electric field. So what is the meaning? Whenever you have a conductor which is under the influence of external electric field, it will create an induced electric field, induced electric field, and because the number free electron density is so high for metal, the induced electric field will have nearly same magnitude as external electric field, right? Here we have mentioned it is going to have nearly same magnitude. It is only true for conductor, and that is the one of the reason why you cannot have dielectric as metal as your dielectric. Because of this, your net force is going to be approaching to zero, because net force is what? Q times E net. Q is going to be charge of electron, and this is going to approach what? Zero, because E net is going to be zero. And then you might ask, then why they are moving? They are moving because the temperature is still more than 0 Kelvin. So even though the net force is zero, they are still getting what? Thermal energy from surroundings, so their kinetic energy is still non-zero. So they are still randomly moving, but they are just accumulated at one of the end. That means again your average velocity is going to be 0. So I net is still going to be 0. So what we understood, even in the case of external electric field, there is no any significant value of current. So how we can get the current? We can see the last case. This was your stage 2. Now we will discuss what will happen when you connect a conductor to a battery. Right, for this purpose you should know one more thing: the role of battery. The role of battery. The purpose of battery is not to produce charge, but rather to make the flow of charge smoother. Means the purpose of battery is just to maintain the flow of charges. Like you can imagine it like a water cooler. So that pump in the cooler, the purpose of the pump in the cooler is not to produce water, just to regulate the water, right? So similarly, this battery, the purpose of this battery is to regulate the flow of charges. And once you connect the battery, the moment you connect the battery, there will be electric field throughout the wire, through the wire till the end of conductor, and this will be known as your electric field due to battery. We will discuss that also. And because this is connected to a battery, again there is electric field. This electron is going to experience some force, so the electron is still going to experience some force, but in this case they cannot get accumulated here, because that purpose of battery is to maintain the flow of charges, so they will not get accumulated here. That means in this case, and here we have mentioned mentioned also that now in the influence of battery, charge can't get accumulated because the battery will make sure the charges are in constant motion. So in that case, E net cannot be 0 because there is no induced electric field, and if there is no induced electric field, E net cannot be 0. In that case, F net will also not be 0, but rather than that it will be Q times electric field of battery. And electric you can see the force, the charges are negative, that means the direction of force and electric field is going to be opposite, so we will write it like this. So in the influence of battery, the charges are going to experience this force, and now because the force you can see is non-zero, so still they have thermal energy, still the temperature is more than 0 Kelvin, so still they will be moving randomly. So the random motion is never going to stop. But in this time, with random motion, you have an additional force which is also pushing the electron in left direction, which is opposite of direction of electric field due to battery. So in this case, what you will have, the electron is going to okay. So in previous case you can imagine like this, when there was no battery, how you can understand the random motion. You can imagine a room, like you can imagine a tight like a room, like say 500 square meter or something, and there are like say 200-300 person, right? And you can imagine that because of some reason there is a chaos in room, let's say because of some fire or something, there is chaos in room. So each one will be running here and there, because, and imagine the room is closed and each one will be running here and there. So even though they are running at high speed, they cannot reach to a point, so their average velocity is going to be 0. So that was the case for this second stage of previous one. But now imagine the same room. So you can imagine a long big room, and let's say the room is fully filled with person, and again imagine the room got caught fire at any corner. So everyone will try to run, and imagine there is only very small gate from where everyone can run out, and let's say 300-400 person are inside the room, and the door is only, the width of door is only like 2 person can pass simultaneously. So each one will be running still at high speed, but the speed by which they will be leaving the door is going to be very small. And this is the thing which you will see here also. There will be electron, and now you can see it will experience force in this direction because there is an electric field in this direction. And because of thermal energy, they will be constantly moving here and there. They will be constantly moving, right? And but in this case, even though they are constantly moving, it was experiencing some force. Now let's call it V1, V2, V3, and this one will be Vn. So even though they are moving constantly, and you can see still the random motion is there, but you can see here in this case the average displacement is not 0. There is some net displacement. I'll tell you what the meaning of this symbol. Now you can see there is net displacement, which is in opposite direction of electric field. Because of this constantly clash between kernel, and see, first I will write the symbols here, lambda, and I will write tau. It will have some meaning. Lambda is displacement between two successive collisions. And tau is time taken between two successive collisions, right? So you can see here also there will be some time before it collides with another kernel. Again, this will be tau 3 and this will be your tau. And similarly, between each collision there will be some distance which is it has traveled, that will be your lambda. Right, so what is your lambda? The distance between each collision, right? The distance between each collision. Tau is time between each collision. So what is the meaning of lambda average? That is your average distance between each collision. That's it is why it is known as average mean free path. Average mean free path. And how would you calculate this? Lambda 1, lambda 2 and lambda 3 over n. Because it is vector sum, that's why we have represented vector notation. Similarly, tau, this will be known as average relaxation time. See, the time taken between each collision is known as relaxation time, and the average of that will be known as average relaxation time. Right? How would you calculate this? This will be a average relaxation time. So in this picture, again, if you see, even though there is thermal energy, because of that which it is moving constantly random direction, there is still a push due to battery, which is doing what? Even though there is constant collision, it is moving little bit more or little bit with the little displacement in opposite direction of electric field. And the time taken to do all this motion and move a little bit opposite in the direction of electric field is your average relaxation time. And the speed by which it moves in opposite direction of electric field due to battery, that speed is known as your drift velocity. And you can see the formula will be like this. So what is average velocity? They are going to move constantly random direction, that is always true. But the speed by which it will move in opposite direction of electric field, that speed is known as average velocity or drift velocity. Right? And furthermore, what is the direction of drift velocity, we are going to discuss in next class. In next class, we will pick from the same topic.